Assalamu alaikum. This question is on conservation of angular momentum. A cockroach of mass m rides on a disk of mass 4m. The disk rotates like a merry-go-round about its central axis at an angular speed omega initial of 1.6 rad per second. The cockroach is initially at radius r of 0.8 r, but when it crawls towards the disk center, what is the final angular speed of the disk when the cockroach reaches the center of the disk? Treat the cockroach as a point particle. So basically we can have a simple drawing of the question. So we have this rotational axis, we have radius of the disk r and mass of the disk m of 4 small m, and then we have here at distance 0.8 r, we have a cockroach that will treat as a point particle, so located at r equal 0.8 r relative to the radius. Then this cockroach will have an initial omega initial of 1.6 rad per second. Then it will start crawling in this direction toward the center until it reaches the center of the disk. Find its angular velocity, angular speed here. Okay. Find the angular speed of the disk here. So basically we can use the conservation of momentum, angular momentum, by saying that L initial should equal L final, and L initial is made of the angular momentum of the cockroach plus the angular momentum of the disk, and this will only give in the final situation the angular momentum of the disk because the cockroach reaches the center. So the angular momentum of the cockroach is made of rotational inertia of the cockroach, omega initial L equal I omega, so rotational inertia by omega, plus the rotational inertia of the disk multiplied by omega initial, because they are rotating together. The cockroach and the disk, they are rotating together in the same system. And then L disk is made of I of the disk, rotational inertia of the disk, by omega final. Now we can arrange the equation because I need to find this omega final of the disk. So omega final will equal I cockroach omega initial, and I can even take a common factor, plus I of the disk multiplied by omega initial. I took omega I as initial angular speed as the common factor, divided by I of the disk, rotational inertia of the disk. But we know for the disk the rotational inertia is half m r square, so we can plug this here, and we know that for this cockroach as a point particle the rotational inertia is basically m r square. So m is the mass of the cockroach, r square means 0.8 r square because it is r equal 0.8 r. So now we can substitute for this. For the cockroach it will be m 0.8 r square plus I of the disk is half m of the disk, which is m of the disk r square. This is omega initial, which is 1.6, then divided by I of the disk, which is half m r square. But we have also another value, or another, that we can get rid of this big M. This big M equals 4m, so we can even replace this, the mass of the disk, with 4 m, and we can even replace it here also, mass of the disk with 4m. Now it can even simplify further. So now the r square, this r square will go with this r square with r square, and the m will go with the m with the m. And if you do this calculation, the final angular speed of the system of the disk is 2.11 rad per second.